Hello everyone, my name is Masma Sultan. Again, I am going to discuss a topic related to geotechnical engineering, which is titled as permeability. So I hope you will listen to it well. Yes, let's start now then. So let us start now. So what we are going to discuss now is, first of all, what is permeability, importance of permeability, Darcy's law applications, Bernoulli's equation, factors affecting permeability, laboratory tests to find the coefficient of permeability. So let us begin this. It is the ability of soil to allow flow of water through it. It is very important factor for the structures which are in contact with water. Flow of water in soil takes place through void spaces which are interconnected. Water does not flow in a straight line but in a winding path here. However, in soil mechanics, flow is considered to be in a straight line at an effective velocity. The velocity of flow depends on size of pores. The importance of permeability of soil is permeability influences the rate of settlement of a saturated soil under load. The stability of slopes and retaining structures can be greatly affected by it. The design of earth dams is very much based upon the permeability of soil used. The filters that made of soils are designed based upon their permeability. Darcy's law. What is Darcy's law? In 1856, a French hydraulic engineer Henry Darcy published a report on the water supply of the city in France. In that report, he described the result of an experiment designed to study the flow of water through a porous medium. Darcy's experiment resulted in the formulation of a mathematical law that describes fluid motion in porous media. Darcy's law states that the rate of fluid flow through porous medium is proportional to the potential energy gradient within that fluid. The constant of proportionality is the Darcy's permeability of soil. It is a property of both porous medium and the fluid moving through the porous medium. In fact, it is the empirical equivalent of the Navier-Stokes equation. If you see that, Darcy's flow velocity for laminar flow is defined as the quantity of fluid flow along the hydraulic gradient per unit cross-sectional area. As you can see the mathematical equation here V is equal to discharge per unit time, K is equal to coefficient of permeability, A is equal to cross-sectional area, and I is equal to hydraulic gradient. What are the assumptions of Darcy's law is that the soil is fully saturated here. Temperature during tested is 27 degrees Celsius. Flow through soil is laminar. Entire cross-sectional area is available for flow and flow is continuous and steady. Some validations are also there in Darcy's law, which states that Darcy's law is valid only for slow and viscous flow. Fortunately, most groundwater flow cases fall in this category. Typically, any flow with a Reynolds number less than 1 is clearly laminar, and it would be valid to apply Darcy's law. Now moving on to the next slide, some of the applications of the permeability are filtration, water treatments. It solves problems related to water pumps, and the design of earth dams is very much based upon the permeability of soil use. Coming to the Bernoulli's equation. Now coming to the Bernoulli's equation. This equation states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. This principle is named after the Swiss mathematician and physicist Daniel Bernoulli, who published it in his own book Hydrodynamica in 1738. Although Bernoulli deduced that it decreases when the flow speed increases, the principle is only applicable for isentropic flows when the effects of irreversible processes and Non-adiabatic processes are small and can be neglected. It can be applied to various types of fluid flow, resulting in various forms of Bernoulli's equation. The simple form of Bernoulli's equation is valid for incompressible flows, most liquid flows, and gases moving at low mass number. As you mathematical equation here, you will come to know about more about the Bernoulli's equation. Here total energy is equal to elevation energy plus pressure energy plus velocity energy. Total head of water in soil engineering problems, it is all equal to the sum of elevation head and pressure head. Now factors affecting permeability. Specific surface area of soil particle, shape of soil particle, void ratio, the degree of saturation, its structure, water properties, temperature, adsorbed water and organic matter. So first of all, the size of soil particle, it varies according to size of soil particle. If the soil is coarse grained, permeability is more, and if it is fine grained, permeability is low. The relation between the coefficient of permeability and from the equation you can say K is directly proportional to D square. If you will go into mathematic equation, you will came to know about it more. Second, the specific surface area of the particles. The particles also affects the permeability. Higher the specific surface area, lower will be the permeability. It is inversely proportional. The coefficient of permeability is inversely proportional to the specific surface area. So third, shape of the soil particle. The rounded particles will have more permeability than angular shaped. It is due to specific surface area of angular particles is more compared to the rounded particles. Now void ratio. In general, we can say that permeability increases with void ratio, but it is not applicable to all types of soils. For example, clay has high void ratio than any other types of soil, but permeability for clays is very low. This is due to the flow path through voids in case of clays is extremely small, such that water cannot permeate through this path easily. Now we will not go into the mathematical equation but only the theoretical. So talking about the structure, soil structure, the structure of any two similar soil masses at same void ratio need not be same. It varies to the level of compaction applied. If the soil contains a flocculated structure, the particles are in random orientation and permeability will be more in this case. Degree of saturation. Partially saturated soil contain air voids which are formed due to entrapped air or gas released from the percolating fluid or water. This air will block the flow path, thereby reduces the permeability. The fully saturated soil is more permeable than partially saturated one. The water properties, the various properties of water or fluid such as unit weight and viscosity we can say also affects the permeability. However, unit weight of water will not affect much since it does not change much with temperature. But when the temperature is increased, viscosity decreases rapidly. Now the temperature also affects the permeability in soils. Permeability is inversely proportional to the viscosity of the fluid. It is known that viscosity varies inversely to the temperature. Temperature also affects the permeability in soils. It is inversely proportional to the viscosity of the fluid. It is known that viscosity varies inversely to the temperature. Hence, permeability is directly related to the temperature. Greater the temperature, higher will be the permeability. That is the reason seepage is more in summer seasons than in winter. Now adsorbed water. Adsorbed water is the water layer formed around the soil particle, especially in the case of fine grained soils. This reduces the size of the void space by about 10%. Hence, the permeability reduces. The organic matter, we say, the last point, presence of organic matter decreases the permeability. This is due to blockage of voids by the organic matter. Now, coming to the next topic, the laboratory tests to find the coefficient of permeability. The first one is constant head permeability test. Now, what is this? It is a common laboratory testing method used to determine the permeability of granular soils, we can say, like sands and gravels containing little or no silt. This testing method is made for testing or disturbed granular soil samples. It involves flow of water through a column of cylindrical soil sample under the constant pressure difference. It is carried out in the permeability cell or permeameter, we can say, which can vary in size depending on the grain size of the tested material. I will not go into the procedure, but a little description. So this is about the constant head permeability test. And what is the variable head permeability test is that it is also one of the several techniques by which the permeability of soil is determined. It is used to evaluate the permeability of fairly less pervious soils. It is used to determine the permeability of fine-grained soils with intermediate and low permeability such as silts and clays. This testing method can be applied to an undisturbed sample. This involves flow of water through a relatively short soil sample connected to a standpipe, which provides the water head and also allows measuring the volume of water passing through the sample. The diameter of the standpipe depends on the permeability of the tested soil. So before starting the flow measurements, the soil sample is saturated and standpipes are filled with de-aired water to a given level. The test then starts by allowing water to flow through the sample until the water in the standpipe reaches a given lower limit. The time required for that water in the standpipe to drop from the upper to the lower level is recorded. Often the standpipe is refilled and the test is repeated for a couple of times. The recorded time should be the same for each test within an allowable variation of about 10%, we can say, otherwise the test is failed. So this is all about the falling head test and constant head test. I hope you will get to know about it more with the research you will do in the future. I can predict that you will do future study also, so you will come to know about it very well. So yes, this is it. Thank you very much.